All right. So it's just a quick welcome to country. So welcome everyone to the UNSW Mathematics Society and CSESoc joint LaTeX workshop. So just a quick check before we start. Can everyone see, the slides and this code and this document over here? All right. So is the size all right? Should I zoom in a little bit? All right. So you can just let me know, like, if I need to zoom in on anything in the Zoom chat. If you want to ask questions in the Zoom chat throughout the presentation, that's fine. If you're on Facebook, it will probably be easier if you join the Zoom meeting so that you can questions over the Zoom chat. But I will have people relaying the questions from Facebook. All right. So just a quick overview of what we're going to do. So the first hour, I want to go through a quick introduction to LaTeX, and then things like how to typeset some maths, how to set up your documents, and a little bit of tables and images. So that should give you everything that you need to do your assignments in LaTeX, essentially. And then for the next hour after that, we're going to go through some more advanced features. So, graphs, diagrams, things that might be useful for CSE, so like source code and so on. And then I do also have some material on extra things like presentations in LaTeX. We probably won't have time to cover it, but all of the example code and all of the slides are going to be put up after the event, and everything's going to be recorded. So everything's going to be sort of like live coding based. So I'll be sort of typing up the LaTeX documents and explaining what I'm doing as I go along. And yeah, feel free to ask me the questions at any time or tell me to slow down if I'm going too fast or anything like that. So why did I decide to run this workshop? Well, this is sort of why. So a lot of courses expect you to use LaTeX in some way. So now the first year maths courses have an assignment. This term for CSE, they're running Comp 312 on algorithms. That expects you to use LaTeX for the assignments. You don't have to, but they kind of suggest that you do. But no course really has the time to color LaTeX. They sort of expect you to teach it to yourself. But there is quite a steep learning curve, so I thought we could run a workshop that helps you get acquainted with everything in LaTeX. So I'm going to do a quick introduction to LaTeX, but first, you might want to get set up so that you can follow along with what I do. The easiest way to do that is to go onto Overleaf. If you don't have an account already, you can sign up with the UNSW email. You get a free Overleaf Pro account. That just makes everything about LaTeX easier. And you get a similar setup to this. So you got to, when you create a new document, you have a place where you can type in all your code, and then a place where the document comes up. You might have to click compile to see a document. But while I get that set up, I'll just quickly introduce what LaTeX is. So all the way back in 1977, Donald Knuth is a famous computer scientist. He was writing the second edition of The Art of Computer Programming. It's this famous programming textbook. The first edition was typeset using this really old method that he really liked. And then by the time the second edition was due to come out, the industry had sort of moved on to this new typesetting method. But he thought, it's not very good. Good quality is quite bad. So as you do, he just decided, I'll just invent my own typesetting language. And this was called TeX. And this sort of gradually evolved. It's very extensible. So LaTeX is kind of like an extension off the top of TeX. And this has just sort of evolved to be the industry standard for academic documents, particularly in like maths, physics, theoretical computer science, anything involving a lot of equations. So yeah, why might you want to learn this? So yeah, as we said before, it's the industry standard in academia for anything that involves like a lot of weird typesetting or equations or diagrams or anything like that. But even apart from that, it's just really neat a really neat way to like format your documents, particularly if you have any sort of equations in it. And you don't necessarily need to be in academia to benefit from that. But the big reason, which is why I'm assuming a lot of you are here today, is that some courses will either prefer LaTeX for assignments or even maybe require it, particularly as you sort of get along with your maths degree or your CSE degree. So this meme is sort of like why I like LaTeX. So Word is great in some senses, right? You can sort of drag pictures around. Everything's, what you see is what you get. If you want a picture to be in a specific spot, you just drag it there. But sometimes that results in chaos, right? You're just you spend ages moving things slightly just to get them in the right spot. But LaTeX is all about simplicity. Like you just say what you want and it sort of lays everything out for you in a way that it thinks is good. And if you want precise control, you can have precise control, but it's very precise. Yeah, so environments. The one that we recommend is the easiest really is Overleaf. So hopefully you've got Overleaf set up by now. If not, if there's any sort of problems, you can mention them in chat and we'll see what we can do. The one that I'm using here is for your own machine. It's called TechLive. So you'll actually like sort of use a compiling command to compile it, kind of like you compile like a program. MechTech is kind of similar. All of these work on Windows and Linux. Mac, I think MechTech works on Mac, but not TechLive. You'd have to use MechTech. And then Microsoft Word, sort of thrown in there as a joke. But it is, you know, there is a use for Microsoft Word. If you're only doing like one maths course, you're not really too fussed to learn LaTeX, that's fine. You can just use Microsoft Word. And Microsoft Word is very good for like if you have a lot of text. So what I use, TechLive. Sure, let me just bring that up. Yeah, so yeah, it's kind of like a compiler and you can use it with whatever text editor you're familiar with. So here I've got VS Code. And then to compile this document, I can just do PDF, LaTeX, and then live.tex, and it spits out a bunch of output, and then I get this updated PDF here. And this is just the standard Ubuntu PDF viewer. But this is a similar sort of setup to what you'd get on, does it work on Mac? I don't think so. I think if you want to use it on Mac, you would need to use MacTech. So here's like a sort of hello world type document to get you started. I've got a little bit of extra stuff here. We will cover what all of this stuff is doing a little bit later. But you can just try copying this for now and trying it out, making sure your setup works. So the important thing here is this bit here, LaTeX with this backslash here. This backslash says that this is not normal text. This is a command. So it creates some sort of special formatting. In this case, it prints the tech logo. And now I'm sure what you've all been waiting for, the maths part, right? How do you type in maths in LaTeX? So we will go over what all of these individual symbols mean, but this is mostly just to show you what maths would look like in LaTeX. So there we go. All I had to do was type that up. On Word equation editor, you'd be fiddling, clicking all these different boxes to try and get everything lined up. Oh, that 2's not there. Oops. In LaTeX, you just sort of type what you want and it comes out. It's a little bit hard to remember what all the commands are at first, but once you get the hang of it, I find it a little bit more easy to use than Word equation editor. I like to just type things out and have them come up. All right, but how do we actually go about typing these equations in the first place? So we have two choices. We can have an inline equation or we can have a block equation. And what do I mean by that? So an inline equation is like, suppose we have x equals 1, right? Let's say that we have like a really small equation. We just want it to appear as part of the text. Well, we can do that with the single dollar signs, the inline equation. But let's say they have a bigger equation, right? Like that sum that we had before. So let's just get that back. Let's say, suppose we have, and let's say that I made this inline. All right, that's a little bit weirder looking. Normally for a bigger equation, we actually want it to be sort of separate from the text. And that's when we have backslash, the open square brace, and then a backslash and the close square brace like that. And that sort of makes it appear on its own line, and then everything's a little bit easier to read. Technically, you can use $2 signs, but this is like old syntax, and it can sometimes cause problems. So we prefer if you use backslash, open square bracket, backslash, close square bracket. Normal symbols are sort of available as is. So like if you want to say like this here, 3x plus 2 equals 0, right? You can just type that out. And if you want to do like all of this to the power of something, you do brackets like normal, and then the up arrow and then 2, sort of what you expect. But there is a catch. So let's say that I wanted to say, actually, this is to the power of 2x, right? Can I just do this? Let's see. No. So the problem is we know that it should be to the power of 2x, but LaTeX can't see that. If you just have the up arrow, it just assumes, all right, the next thing I see after the up arrow, this is the power part. So to tell LaTeX that actually we want the whole of the 2x to be up there, we have to use these curly braces like this. There we go, all to the power of 2x. What if we wanted like a Greek letter? So you have to use the full name of the Greek letter. Programming things in LaTeX is a very easy way to learn the names of all the Greek letters. So we could have alpha there, or let's say we have, let's say gamma up here. There we go. Could I zoom in a bit on this code? Sure. All right, so what do we want to do with a fraction? Let's say this is not equal to 0. Let's say it's equal to 1/2. I could just do 1/2. It's fine to have an equation like this, right? It's a pretty small fraction. What if I wanted to do x plus 1 over x plus 2? I just do that. Yeah, see now it's not as clear, right? Is this x plus 1 over x plus 2? Or is this x plus 1 over x plus 2? So we really want like the sort of full form fraction for this. And that's where we have /frac. And we have our curly brackets around the x plus 1 and the x plus 2. And there we go. And you can have sort of as many of these nested as you want. So let's say you wanted to do like a repeated fraction here, plus x plus 3 over x plus 4. Yeah. The fraction is getting a bit unwieldy now, but LaTeX can still handle it just fine. All right, so we already looked at what are the backslashes for. So the backslashes is sort of saying that it's a command. So let's say that I left out the backslash there. I just have frac. LaTeX can't tell that by frac, I mean, I want a fraction. It just thinks by frac, I mean the variable f, and then the variable r, and the variable a, and the variable c. So the backslash sort of makes LaTeX aware that we want a command there. If you want to actually type a backslash, I don't know how you do that in maths, but in the text, you do text backslash, like that. So backslash is itself a command if you actually want to type a backslash. Okay, so the round braces, they're just for typing. So like you want to type a round brace around, sorry, the parentheses here, right? But if you have curly braces, that's for saying like, they're kind of like the LaTeX version of brackets. So it's saying like, this should all be to the power of 2 times gamma. If you do actually want to type curly braces, you have to use a backslash to sort of say, this is an actual curly brace, this is not part of LaTeX, like that. I'll zoom in a little bit more. All right, so let's take a look at some sums and some integrals. So let's say I want to define a function. We'll make this a function called f alpha. We sort of saw what a sum is like before. So sum up to n. The underscore here is saying like, so the up arrow n, when you're talking about a sum, is like, this is the upper limit. The underscore is saying this is where it starts. So you have the like k equals 1 underneath, and then whatever is in the sum. So 3 to the power of minus k. But there's a problem with this, which we'll see. Right. So that's not what we expected, right? We want 3 to the power of minus k. We don't want 3 to the power of minus and then k. Well, this doesn't really make sense. And it's the same issue as we had before. So oh, that's cool. You can zoom in yourself on Zoom. Oh. That's very useful. Yeah, it's hard to get everything that's needed on the screen at once, unfortunately. I'm glad that Zoom has a feature for that. Yeah, there we go. But what about integrals? So integrals are a sort of similar setup. So you can have, so slash int has the integral sign. The up arrow is like the upper bound of the integral. So say this goes to infinity, which is int ty. It's quite annoying that only some of the letters are missing, but yeah. And then we'll say, let's say e power of minus x squared dx. I'll put an alpha in there actually, because it's a function. Actually, this is a good point. What if I just did this? Right, it's not updating here. On overlay, if you get like a squiggly line here that says this same thing here, undefined control sequence here, alpha E. So undefined control sequence means LaTeX encountered a command that it doesn't recognize, right? Now, we understand this as like alpha times e to the power of whatever. But unfortunately, LaTeX is just going to see that as alpha e. And it doesn't know what that means. So one way that we can deal with this is we can just put some empty curly braces around that. The other way is to just put a space in there. When you're inside maths mode, spaces don't really matter. So what about this dx here? Let's say that I remove this power here, right? I just have alpha e. Right? The e and the dx are really close together. Even if I put hundreds and hundreds of spaces, they're still close together. So how do we insert space in maths mode? So what I've done here in the slides, what you can do is you can do backslash and then semicolon. And then I'll just add a tiny bit of space to help separate the dx from whatever's inside the integral. And one other thing that I don't do this, but some people like to do it, is you might want the D to appear like, you know, a sort of upright D, not in italics. You could do math RN D. And that gives you the sort of like uppercase D. Some people prefer to do this for integrals. I think it's fine to have the normal D, but all right. And now I'll just, okay. Now we want to say where I have an inline thing here, alpha, backslash in is like the set inclusion symbol, and then math BBR. So this means math blackboard, and it uses the blackboard font, which is what you use for like that fancy, real numbers are. I'll just zoom in a little bit so you can see that. So this is something that's provided by one of these packages up here. I'll explain what the packages are doing a little bit later. The easiest way is to just include these in all of your documents, just in case. Because particularly for maths, you'll find that you use them more often than not. So yeah, we can have like special font faces. We've also got MathCal, which is like the fancy sort of handwriting style. There are all sorts of different fonts. You can sort of look them up to figure out what they are. All right, now, if there's one thing that I want you to take away from this workshop, apart from just like generally how to use LaTeX, it's this. So let's have this function here, right? Sine x plus, we'll have this in brackets because it's all to the power, frac pi over 2, all to the power of n. Right, now it's clear what I mean by this, right? Sine of x plus pi over 2 to the power of n. But it looks a little bit weird. So one thing is that the sign is in italics. It shouldn't be. It should be just like normal text. And the other thing is these brackets around pi over 2 are not like appropriately sized. We expect them to sort of surround the pi over 2. But the pi over 2 sort of outgrown them. You'd be surprised how often this happens, even in things like course notes and lecture notes and all that sort of stuff. It's quite easy to forget to do this. So one thing we can do is to make sine look sort of as we expect. When they made LaTeX, they figured out that people are probably going to want to use things like sine and cosine a lot. So we'll just make them commands. So you can do like /sine, and that's a perfectly normal command. So that's one of our problems fixed there. What about the brackets? This one is quite annoying. So for all of the brackets that contain something that's really tall, you want to put /left before all of the left brackets, and /right for all the right brackets. Yes, we will be releasing the notes after the workshop. So all of the examples that I'm going through and also all the slides and so on. Yeah, there we go. So this is looking quite a lot neater. So a sort of natural question, it's like, all right, so, LaTeX has all of these functions built in, but what if I have my own function, right? We'll go back to like sine x, for example, all right? Let's say that I wanted to do CIS, which is like, let's say CIS pi over 2. This is like a for you thing, I think, which is like e to the I theta, kind of. All right. This is not particularly common, so I can't just do slash like that. It's going to give me an undefined control sequence. So how do I make this look like it should? Now, one thing you might want to do is put it inside mathrm. I'll make it appear upright, but it won't add the little space between it and whatever its argument is. So this looks a little bit weird, right? It's like syspi, all one word. Easiest way is to do operator name. And this also adds a little bit of space just to make it that bit easier to read. You shouldn't normally need to do this. So most of the functions that you deal with, things like, log, ln, all the trigonometric functions, they should all be like predefined as a command. So we have some equation environments. I'll go back to our function. So one thing that you might want to do, we'll have this. You might want to have this equation and then refer to it later on. So like looking at the equation, let's say referring to the equation above, right? So this is fairly common. But what if you wanted to refer to it by number, especially if you have a lot of equations? That's pretty useful. So one thing you can do is you can use begin equation and end equation like this. And then that automatically gives the equation a number, which you can use to refer to the equation. So you can say like now referring to equation 1, like that, which is pretty neat. It's kind of useful, but it's one thing which is very useful. So let's say that I wanted to have some working out. It's pretty clear that this is actually equal to, take all this stuff out again, put it here again. We just take the alpha out, right? Because it's constant. Let's say that we have some more lines of working out, right? You want to actually solve that integral with the fancy equation. I forget what exactly this integral reduces to, but you can reduce it to something. It's going to take a lot of lines of working out. It won't fit in one line. What if I just put in a new line here like this, right? Well, oh, interesting. That actually causes an error. I expected that to just not do anything. What if we did this? What if it's the equation environment's fault? What if we just did that? Yeah, okay, that's not working. So I want a way to have like, kind of like how you do it in your notes, right? So you have an equal sign, you do one line, and then you have another equal sign that's sort of lined up below that. That's where we use our align environment. So end align here. Now, what align does, I'm aligning it inside the, we don't actually have to do that. We can just do this, right? So for align, you put 2 backslashes at the end of each of the like lines in your equation. And you put this ampersand before all of your equal signs, so all the things you want to align up to. And then that will like line up your equations. And if you have a lot of different lines, so let's say that we have like another line here, let's say that we reduce this integral to some other function. So g of alpha, right? All right, so we have this weird glitch here. And that's because we forgot to put the double backslashes there. There we go. Now it is adding a new number to each of these lines. This is kind of useful if you want to like refer to a specific part of the working out. So like on line 2 of this, we introduce this thing, but it can get quite annoying. So that's where you have the align star environment, and that just removes those numbers. I use this a lot. I really like to use this. Right, so this sort of begin and end, we call this an environment. So an environment sort of styles everything within that environment in a particular way. And we can have environments within maths mode as well. So let's say that, what if you only want to number 1 of them? That's a good question. I'm not sure how you would do that. you'd probably have, tag, thank you, Rui. Yeah, the way that I normally do that is I would just say like referring to this bit, like the second line or something. But let's say tag. Yeah, there we go. Thanks, Rui. So let's say that we wanted to have like a matrix. Matrix can't really be a function. Let's say A equals I'll change this back to a normal equation. So we can use P matrix to have like round braces around an equation. So let's say this is 1, 2, 3, 4. So this is kind of similar to the align environment in that you have to have these ampersands to like line up all the columns and then 2 backslashes on the end of each line to say that this is a new line. So this gives us a 2-dimensional matrix. You can also have B matrix if you want it to have square brackets, which is how I'm used to writing matrices. And you can also have, this one is also particularly useful, the cases environment. So cases lets you define piecewise functions. So let's say that I want to have the absolute value function. So actually this is x like this, right? So this is x if x is greater than or equal to, which is GEQ 0. Or if it's less than 0, it'll be minus x. So we could say like x less than 0 here. So let's just define something using like multiple different cases. Or we can have this just be otherwise, which is also fairly standard. Well, that comes to the end of everything we're going to do for equations. Are there any other questions about maths or equations in the text? How do you get a new line between lines? So is this within an equation or is this just within the document? Both. Okay, so let's say that I want, we'll go back to our, go back to this working out. Let's say I want to add a blank line here. I think it would just be something like this. Yeah, so you just do like the 1 ampersand and then the 2 backslashes, and then I'll add like a little bit of space between them. If you want a new line in text, the one thing that I think is confusing about LaTeX is, let's say that I was like, down here, I put a new line, I'm like, now moving on to question 2, like this. It doesn't work quite how we expect, right? There's no new line. That's because 1 new line in LaTeX is ignored, but if you have 2 like this, it makes it a new paragraph like that. The other option is to do the 2 backslashes like that. I don't recommend this though, because it doesn't add any like space between them. If you want more space, you can use v space like this. So let's say I want like 3 centimeters. Wait, whoops, I think it needs an extra space there as well. Yeah. Is there a way to comment? Yes, there is. If you use a % sign at the start of a line, then yeah, it'll just turn that into a comment. It's very useful for like commenting out parts of the document, but also for like leaving notes for yourself. All right, document setup. So we'll come back to what we had before here. So I told you to ignore all this stuff before, but now we're going to unignore it. We're going to go through it. So we have all this stuff, and then we have begin document. So document is kind of like an environment, but that just says this is everything that's actually going to appear on the pages of this document. All of this stuff is sort of like set up for the document. So we have the document class. This says, what is it that we're making? But for the most part, the document class that you'll be using is article. You don't have to use it for articles. It's pretty versatile. You can use it for pretty much anything. I use the article document class for my CV. The other document classes you might come into are book. So if you want to typeset a book, the book document class has a lot of extra features for that, things like chapters and so on. And then also Beamer for presentations. So this presentation I made in LaTeX, and I used the Beamer document class for that. And then there's also use package. So I've included 4 different packages here, which I think are useful. We'll go over what those are in a little bit. But one package, which I haven't included yet, which you might find useful, is the geometry package. So LaTeX is an American invention, and so the default paper size is the US letter, which is very similar, but not quite the same as A4. If you want A4 paper, you either do this here, this like A4 paper option for the article document class, or you do A4 paper geometry like this. And once you have that, you don't need this option anymore. And then that sets the page size to be, and you can choose any sort of page size you want. So you could have it like, I forgot to add the so you can have it be like A5 or A3 or anything like that. But the one thing which I think you'll probably be interested in is the margin size. So let's say that I have like a really long paragraph. Hello. Blah, 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 blah. Just paste that a little bit so we know it goes over a line. So you'll notice that these margins are quite thick. There is a very good reason for that. So when they were inventing LaTeX, they did a study that was like, what's the optimal number of words that should be on a line to maximize attention? And it turned out to be this like specific number. And so what they do is they look at the size of the text and then they figure out the optimal margin size, but it tends to be quite big. For an assignment that only has like 1 or 2 lines per paragraph, it's probably too big and then causes you to have like a 3-page assignment when it should really be 1 page. So something you can do is margin equals, let's say 3 centimeters. And that gives you a little bit more room. Or you could do margin 2 centimeters. That gives you quite a lot of room. One other thing, which is kind of unrelated to the geometry package, is you can say, I want a 2-column document like this, which is fairly common for like actual articles that get published in journals. You probably won't use it for your assignments though. But it's useful to know about. So we can also use the preamble to set up some document metadata, which is like pieces of information that describe the document. So we have a title, tech workshop. We can actually have commands in here. So author, let's see, Nick, and then date. /today will put in the day that you compile the document. So whenever you click compile in Overleaf, or you run the compiling command like I'm doing here, it figures out the current date, puts it in the document. But you can trick your lecturer into thinking that you did the assignment on an appropriate day, like a few days before the due date. So 1st of July, 2020. Yeah, of course, it's not going to work because you'll be submitting it, right up at the deadline, and the document will have a last modified time that says you just changed it a few minutes before the deadline. But it's nice to have this sort of, well, look, I did it a few days ago, but this hasn't actually appeared. So because this is in the preamble, it doesn't actually have any effect on what's in the document yet. We have to use a command called makeTitle to actually draw it out for us. So there we go. It's a really nicely formatted title block like that. And we can have, ZIDs and so on. So let's say Nick, my ZID there. Now, what if I wanted to add like another person? So this is kind of like before. I can't just sort of add new lines in and say like Nick 2. I'm going to get an error. It says paragraph ended before author was complete. So we can only have one paragraph in there. What we can do is we can have the 2 backslashes there. And they're not allowed a new line. So that's useful if you have like a bunch of people working on one assignment. And now these other packages that I promised to go through before. So AMS Math and AMS Sim, you basically need these whenever you're doing anything that's vaguely related to maths. So AMS Math has things like the align environment and so on. And AMS Sim has things like the real number symbol and all that sort of stuff. Microtype is something which makes very slight adjustments to all of the text in your document that makes it a little bit easier to read. It's always a good idea to include that. And then parskip. So if I just comment this out, then by default, LaTeX adds this like space on the start of each line, on the start of each paragraph. This is sort of a matter of personal preference. I don't like the space, so I always include the parskip package, particularly considering that assignments usually have like 1 or 2 lines per paragraph of explanation and then a big equation. So generally not very useful, but that's up to you. What about sections and subsections? So let's say this is question one, and then here we're going to have question 2. Now moving on to question 2. We're going to have part A, find all solutions to that. Then part B is going to be so something like this, right? And this is a fairly typical layout for an assignment. You have questions, the questions have parts in them. But this isn't particularly visually distinct. We want like a heading that sort of sticks out to make the document easy to read. So one thing which you could do, I suppose, is you could make them bold. So if you do text BF, that makes text bold. Or if you do text IT, that puts it in italics. So that's kind of nice. But we also want it to be bigger. And you can change the font size manually. But as with everything in LaTeX, it'd be easier if there was just like one command that just sort of takes care of all the formatting for us. And there is. So we can do /section to say that we want to have different sections. And then also for these different parts, we can have subsection. And you can go on to have subsections and so on. Like that. And the other neat thing about these is if you include another package called the hyperref package, this probably isn't too useful for your assignments unless they end up being very long. If you include the hyperref package and you do hyper setup bookmarks equals true, you do have to compile twice to get this. But if you look on the menu section of the PDF viewer, I'm not sure if you guys can see this very well, but it actually puts in like a little summary, kind of like Word does, where you can click on these and then get taken to part of that part of the assignment. So let's say that I put question 2 on a new page. All right, if I click on question 2, it takes me down to question 2. Yeah, it's very useful if you're doing like a thesis or a really long document, because then you can just zoom to a particular part of it. You can also use sections and subsections to automatically generate a table of contents. We probably won't get to cover that in the talk, but it is in the slides if you want to take a look at that. But there is one problem with this, which we'll go into now. So having like question 1, 2 question 2, it's a little bit redundant. So to get rid of the numbers, you can do section star like this, and subsection star and so on. Kind of like a line start that turns off the counter that figures out where it is. So yeah, now you got question 1, question 2. Problem with this is if I compile it again, the little bookmarks go away. I'm not sure how you would get those back with having section star and so on. But yeah, it seems like you could only have one or the other. All right, tables and images. So, all right, we're coming off the end of this sort of homework assignment. We're moving on to like a report-based assignment. So let's say that, just get up this report. Let's say that we want to have a report that summarizes like how cool and how awesome a bunch of different animals are. So let's say humans, coolness 3, awesomeness 0, right. Parrots, coolness, we'll say 400. Awesomeness, we'll give them 1,000. And then bees, uh, $3,000. And we'll put some new lines in. So this works, but it's not an ideal way to present information, right? Normally for something like this, you'd use a table, and we can have tables in LaTeX. So 200. But there's one thing that's sort of typical for a table, which is missing here, which is all the lines. So to get a horizontal line in a table in LaTeX, we do hline like this. And then to do the vertical lines, we want, all right, sorry, I think I disconnected again, but I think it's connected. So we'll keep going. So the motto of tables in LaTeX is to just use this package book tabs. So we don't need to worry about vertical lines like this. We can just do top rule, mid rule here, and then bottom rule. I'll get rid of all this stuff. And that's sort of taking care of the formatting for the table for us. So there are a bunch of different column types that we have available. So we have L, which means align the text all to the left. C, which is put all the text in the middle. R, which is put all the text to the right. So we're using L and R here. So L for this column and then R for these columns. And then P is quite useful if you have a lot of text. That's just like align it to the left, but make sure it's like a fixed width and then add extra lines if it goes over this width. So that's quite helpful if you have like a big block of text in part of the table. Extra note that sometimes if a page contains like a really wide table or a really wide figure or something, you want to make it landscape. And there's a package called PDFplots that helps you do that. Yeah, so let's say that we wanted to add some images in. All right, thanks for coming. All right, so we want to add some images. We can use GraphicX for that. So include graphics. Let's just copy in my image. Let's say I wanted to include this picture of a parrot that I took. Right, I could do, now I've included this package, included this package GraphicX. I can, I want to recompile it. There we go. So now I'll put my image in, but this is quite big. I don't really want this massive photo of a parrot taking up all the space. So one thing that we can do is we can limit the width. So we say width equals 5 centimeters. All right, there we go. So that's a little bit more of a manageable size. Now, the ability to include images is fairly useful because a lot of things to do in LaTeX you can do, but it's hard. So things like graphs or diagrams. We will hopefully cover a little bit about how to make those in LaTeX, but it is quite hard. Sometimes it's easier to just do it in another program, take a screenshot or something, and then put the picture in. Now, another thing is, it'd be nice if I could sort of label these. So, you know, put them in the middle, give them a caption, have everything sort of nicely laid out. And that's what figures are for. So it helps us sort of do things like control the positioning, put them in the center, add a caption. So use the table environment to do this for tables. And then we do centering to put it in the center. And then we can say table of coolness and awesomeness. So a natural question is, well, where did it go? It's just disappeared. Well, if you look carefully, you can see that LaTeX has quite helpfully put it right at the bottom of the page. So sometimes you need to be a little bit more specific about where you want things, which is these position specifiers. So T means put it right at the top of the page. Sometimes LaTeX won't listen to you and it will say, no, it shouldn't really go at the top of the page. If that's a bad decision, I'll just put it on a new page. H means put it right here. So we do H, it's basically where it should be. B means put it at the bottom of the page, which is what it was doing before. And then P means just put it on a page by itself. So what I would recommend is use H, because that's sort of like a natural choice. And then if you find your page is getting too crowded or the figures aren't going where they should go, or there's a lot of them, switch to P and just sort of give up and put them all on a dedicated page. So I'm going to go with H. And then for images, it's figure. So begin figure. photo of a parrot. Oh, and we want to put that, get that H2. Yeah, there we go. And it gives them a number as well. So like, let's say they have another, let's say I wanted to have a bee. I'll have another figure, and that's going to be the photo of the bee. So this is labeled as figure 2. So we're about to come into our second half, which is all about graphs and diagrams. Are there any questions about like tables and images? All right. Do let me know if I'm going too fast, or if there's any other sort of questions that come up later on. I will be checking the chat, so feel free to ask. So we'll move on a little bit to graphs and diagrams. How would you make horizontal column lines in tables? Okay, so by that, do you mean like a line to separate columns? Yeah, okay. So with book tabs, it doesn't, you can do it actually in book tabs, but it looks a little bit strange. So like that. But you can see that book tabs has these like extra spaces around its lines that make it look a bit weird. If you want to have those kinds of lines, then you would just, you have to change these as well. You would use something other than book tabs generally. You just use the default built-in tables. Yeah. So like that. I prefer the way that book tabs looks personally, because I think it adds a little bit more space. And their advice was basically that you don't really need the vertical bars in tables, because the lining up of the text is enough to sort of separate things. But there are some cases where you would want the sort of Excel style tables. So in that case, you wouldn't use book tabs. You use traditional like H-line and these vertical bars when you specify your columns. So moving on to graphs and diagrams. So here's an example of a graph in LaTeX. Right, this is not like a screenshot. This is purely done in LaTeX. When you compile the document, it actually runs the equation for you. It figures out the value of this equation at different points and plots this 3D graph. So you can do some quite powerful stuff with graphs in LaTeX. Technically, it's graphs in PDFplots. So I'll explain what that means now. So we'll get rid of all of the stuff that we did for this report. We're going to do a slightly different report. So LaTeX is really good for paragraphs and equations. That's sort of what it was designed for. Some people then said, well, we want to do some graphs in LaTeX as well, but it's not really good for graphs. So we have to use an entirely new set of commands for doing that. And that's what PDFplots is for. So you can do things like graphing raw data, so like scatter plots, or we can do like actual mathematical functions. So we just type in the function and it plots it for us. We can also do 3D graphs. I won't cover how to do those, but you can look that up, or you can look in the slides. So as part of releasing the slides for the talk, I'm also going to release the source code for the slides, since the slides were done in LaTeX. And you can have a look at that. So I'll just get up my notes for this bit. So to get started, we'll want another package called PDFplots. And it requires you to also use this command to sort of set the version of PDFplots that you want to use. Let's say that we want to have a scatter plot. So I've got some data. I'll just copy it over. Oh, whoops. So down here, I have a file called data.txt. And in this file, I've got 3 columns of data. So the first one is the number. So this is describing an algorithm. If the cell value is too long in the table, should we use 2 backslashes to break down into 2 separate lines? Yes, but normally if you have a cell which has content that's too long, you'd want to use the P column specifier. So that's short for paragraph, and it aligns things to the left. But if things are too long to go on one line, it automatically breaks them onto the next line. Normally you have to specify a particular width you want to use with that. So you do like, so inside the column specifier, you do something like P 5 centimeters, like that. And then that's like, once the text is longer than 5 centimeters, break it onto a new line. And so I have some data like this. This is describing an algorithm. So this is the number of inputs to the algorithm. This is how long it takes my algorithm. And then this is how long it takes other algorithms. So as you can see, other algorithms, the performance suffers quite poorly, but my algorithm is really good. So I want to just draw a graph to show that off. And I want to use this data that I have already. So let's do begin. So for a graph, I want to do text picture. That's misspelled, text picture. And then I want a pair of axes, so begin axis and end axis. Let's just draw my algorithm in to start with. So for that, I can do add plot. And then table. The X values are going to be this number column, so number of inputs. The Y values are going to be my algorithm, so Nick. And then it all comes from data.txt. And because this is PDFplots, everything should end with the semicolon. A little bit of a weird trick to that. All right, there you go. So it's plotted this stuff for our algorithm, and then helpfully it's also like drawn all the axes for us and figured out an appropriate scale. But there's one thing that we're probably all taught in science, which is if you have a scatter plot like this, don't connect the dots. There shouldn't be a line there. So to get that, you do only marks like this. All right. And then we can add on the other data. So the other one, the Y value is other. So the column starting with other. There we go. So you can see that one of the algorithms is particularly better than the other one, but now we don't know which one is which. So the other thing we can do is we do, we'll say that my algorithm is going to be the red one, and then the other algorithm will be the blue one. Why doesn't that work? Oh, it's American. There we go. So now we can see that the red algorithm takes less time than the blue algorithm, but we still don't know which is which. So one thing we can do is we can have a legend. So we do add legend entry. Nick's algorithm. Other algorithms, like that. There you go. All right. So now it's pretty clear what's going on here, right? What's something else that you might want to do? Well, it might not be clear what these, the different axes are talking about. So like what is 0, 200, 400, 600, and so on. And then what's 0, 500, 1000, 1500. So this is like an option that we put up here with the axis. We say the X label, so the label for the X-axis is number of inputs. And then the Y label is time in seconds. There we go. So it's labeled it for us. And then what if we wanted to only have the axis lines on the left? This is pretty common, particularly if you're like graphing a function, right? It doesn't make sense to have this sort of box around the whole thing. This is where you do axis lines equals left, like that. There we go. And this is a figure, just like anything else. Or I should say it can be a figure. So we can do begin figure and then end figure here. And then we can do centering. And then we can do experimental performance like this. Oh, axis line sensor, yeah, very good. That's good if you're dealing with like negative values and that sort of stuff. Yeah, so there you go. So we can have like a label, and we can put it in the center and so on. So what if we wanted to also draw some functions? So we actually wanted to draw something out mathematically. So it's a similar story. So we have begin, actually I'll just copy this. Begin text picture and all that sort of stuff. But instead, we will have just a function. So let's say add plot. Let's say I wanted to do sin x to start off with, something that's kind of distinctive. Actually, it's picking a weird scale, I think. I think it uses degrees by default. Yeah, sine, convert x to degrees, x. There we go. So we can plot anything you want for you. And the way to make it look smoother is you can do samples 100, let's say. And it takes a while, but you get like a really smooth looking sine curve. And you can do similar sort of things to this. So you can make them have a color. So this could be like color red, and you could give it a legend entry. These can contain maths. So you can do like, here you could do fx equals sine x, like that. Or add legend entry, oops. Yeah, there we go. I'm going to turn down the number of samples because it's taking quite a while to compile. And you can graph pretty much any function you can imagine in this. It's quite useful. So there's a lot of things here. There's a lot of syntax to memorize and a lot of different things you can do. So what's the best way to learn what the right syntax is? Unfortunately, the best way is just to use Google. You sort of find something you want to do, like, oh, I want to know, how do I put a point on the graph? The best way is to just look it up. Doesn't that take quite a lot of time? Yes, it does. You'd be right in thinking that. So if you're strapped for time, particularly if you just want to get this assignment out of the way, the easiest way is to like open up something like GNUplot, AskGDO, Desmos, whatever, take a screenshot and just use include graphics to put the screenshot in your document. This is just if you want things to look like really nice and really neat. What about some sort of diagram, right? I don't actually know the answer to this question, but this is like an example of all the different things you can do with diagrams. So you can have mathematical symbols in the diagrams, you can shade things in, you can do like composite shapes and so on. Well, let's look at a simple diagram. So in a similar vein to PDFplots for doing plots, with diagrams, LaTeX isn't really good for diagrams. It's better for things like equations and typesetting and so on. So we needed a separate language entirely to handle diagrams, and this was TIX. So to include TIX, you have to do use package TIX like this. And we have a bunch of drawing shapes we can use. So we also use TIX picture for this. So let's say that I wanted to draw a circle, blue circle. So fill draw blue at position 0, 0, circle with radius 1 centimeter. All right, there we go. We have our blue circle. And all of these coordinates are relative. So let's say that I wanted to have a red circle that was 2 centimeters, I'll say actually 3 centimeters to the right. We can just do a positive 3 there, and it will sort of adjust the position of everything. Well, let's say we wanted to have a green circle that was 3 centimeters to the left. We could do -3. And that won't actually be like off the edge of the page. It will just sort of push everything along like this. So what other sort of things can we do? So we can also do lines. So let's say that we want to have some lines coming off this circle. So we can say draw from -1, 0 to -1, -2, and then draw 1, 0 to 1, -3, like that. Right, so now we can draw some lines. We can also draw any sort of shape we like with fill draw using this path thing. So let's say that I wanted to draw a triangle coming off one of these. I can do fill draw red 1 -3, 1.2 -3.3 to 0.8 -3. Should be -3.3. And then at the end, cycle to say, go back to the start. There we go. So these 3 points make up a triangle that's dangling off the edge of this. And we can also draw labels on these things. So let's say that we wanted to have, let's say we wanted to label this thing. We can do node, try to label, at 1 -3.3. Let's say this is 2 kilograms, this weight here. So got a nice label. The problem is it's actually embedded inside the shape that we're labeling, right? Because we did 1 -3.3, that's actually technically inside one of the lines. So one thing you can do is you can like slightly adjust the coordinates to make it a bit below. But the easier way to do this is to do anchor equals north. So what that says is this thing is labeling something which is to the north of it on the page, so just above it. And then that will move it down a little bit so that it doesn't, crash into whatever it was about to label. And you can also do maths in here. So let's say this is like m pi kilograms. Yeah, like that. So this is very useful if you're drawing diagrams, particularly for something like physics. So this is sort of like a pulley sort of setup. Probably move on from graphs and diagrams here. There's quite a lot to take in. Are there any questions about like graphs or diagrams? All right. So there's a little bit of stuff in here about extra document features. We'll probably come back to that if we have time. But given the algorithms is running this term, I thought we might cover a little bit of stuff for CSE. So we want to cover things like source code, pseudocode, and there's also some notes in the examples in the slides about finite state automata, but we probably won't actually get to cover that. But it's there if you want to look at it. That's particularly useful if you're doing sort of theoretical stuff for computer science. So we've just been talking about this algorithm. What if I wanted to actually show people what the algorithm is like? So, show them pseudocode, show them source code. So we can have small fragments of source code in the document using text-tt. So I could say like, then we is prime and let's say, right? So this makes it monospace, kind of like code, but it's not sustainable to write a whole program in this way. So there's a package for this, the listings package, that lets us put in snippets of code in our document. Oops. So I have some C code here in a separate C file, and I want to include this code into my document here. So the package that we use for this is listings. And then what I can do is just do begin and end LST listing. I'll just copy this code, paste it in there. Let's compile this document now. All right, so it has like lined up all the characters as if it was monospaced, but there's a problem, right? It's not very visually distinctive. It's using the normal serif font, which is a bit weird looking for code. Yeah, it'd be ideal if we had some kind of formatting. So there are formatting options for listings. And here are some which I prepared earlier. So what this says is put a box around the code, make the font size small, which is very useful because the amount of code tends to actually overflow the length of the document. And then set the tab size to 2. That also helps like control overflowing the page. And now it's formatted a little bit more neatly. That's looking really nice. We can also have a caption. So let's say caption my algorithm implemented in C. There we go. That's just like a figure, right? But the problem is, what if I have all of these lots and lots of C files? I don't want to have to copy and paste them all in here. So for that, we have lst input listing. And then this just takes a file name as one of the arguments. We don't have to paste any of this. In fact, this is actually a command by itself, just lst input listing. There we go, exactly the same. It just reads the contents from the file. So this is very useful if you have some kind of document where you're using source code and you want to provide the source code in like an appendix or something. You say, here's the source code I used. But you don't always deal with source code, right? Sometimes you want to deal with just pure algorithms and you want to use pseudocode. So there's another package for that called algorithm2e. Yeah, so simple pseudocode can probably use enumerate. That's something that we'd normally cover inside the extra document features section. So enumerate is basically like, so step one would be like load all numbers into an array. Sum in positive numbers in an array. Return. So it lists things out in steps, but for a more complicated pseudocode that involves like if and else and then for and all that sort of stuff, you want a dedicated pseudocode package. So that's where we have algorithm2e. And as always, there are a bunch of options that come with this. When I was doing my assignments, I just kind of messed around with the options until I got something that looks nice. So I'm just going to put them here. These basically change all the spacing that's used by the package to make everything look nice. So in the interest of time, because it takes quite a while to type out, I'm just going to copy what I had before and explain my way through it. So unfortunately, there's no way to load this from a file because it handles a lot of formatting. So it uses a lot of LaTeX commands. But you can sort of type things out using commands. So this is don't print semicolon means don't put a semicolon on the end of all the lines. You don't really need semicolons for pseudocode. So data is like the input for your algorithm. Result is like the result of your algorithm. You can freely use maths inside it, which is very useful for pseudocode. And then begin contains all the code for the algorithm. So we have a for loop. So for all A in this array, capital A, if A is greater than or equal to 0, we should probably actually do GQ like that. Then set S to be S plus A, else set S to be S plus minus A. And then TCP and TCC are sort of adding comments into the pseudocode. All right, thanks for coming. And then just return S at the end. And then we can have like a caption for it as well. So yeah, it sort of formats everything really nicely for us. Everything's in serif fonts, which is nicer for pseudocode more than anything. The keywords are in bold. It's added lines to sort of show where all the control flow is. We can have as much maths as we like. And the comments are all in monospace text. So then we have a caption at the bottom. The documentation for algorithm2 contains all the sort of commands that you might want to use. So I'll just link that in chat. This is one of the LaTeX packages where it's probably helpful to actually read the documentation if you're ever going to use it, because there are all sorts of different commands that you want to use as part of pseudocode. You might not necessarily find them on Google. All right, are there any questions about like algorithms or source code listings? before we move on to like other documents and features. All right. So yeah, let's go on to some more document features. So we looked a little bit at one, which was enumerate, just kind of list. So there are all sorts of other like helpful formatting features, which can sometimes make your assignments quite a bit easier. So yeah, we already talked about sections and subsections. You can also, if you have a really long document, you can use /table of contents. And it's really like as simple as that. You just put /table of contents, and you do have to compile the document a few times because of some technical reasons about how LaTeX figures out where all your headings are. But it will actually generate the table of contents for you automatically and just put it right at the front of your document. It's very helpful for like a long thing like a thesis. You can have like customized headers and footers. So some assignments, they might say like, all right, you should have your name with ZID in the header, and you should have this particular thing in the footer. You can use the fancy header package to help with that. Look that up. You can also use TitleSec to change the way that the titles look. So you might want to use like a small caps title, for example. Links and references. So for most of you, you might not be dealing with many references, particularly with like first year assignments. Maybe you like reference something from the lecture slide. So let's say that you had like, let's say, since these vectors have a dot product of 0, they must be, they must not, they must be parallel. Been a while since first year maths. I think that's true. So let's say that we wanted to like cite that. You can say like footnote from the lecture slides, week to slide 5. So this adds like a little footnote here. You can actually click on it and it will zoom down to the footnote there, which is very useful. So for most assignments, this is probably enough for referencing. You just say like, okay, this is according to this one web page or this one section of the course notes. If you're doing a bigger assignment, which has a lot of references, you probably need like proper bibliography management. So you use Bibliotech for that. And I think the UNSW library website will actually provide you, like if you have a resource on the website, on the UNSW library website, it provides you the right BibTeX code that you can just paste into your bibliography and it handles the references for you. Perpendicular, yeah. You can see why I dropped my maths degree. So you can also add clickable hyperlinks to web pages using href or URL. So let's say, runaway argument. I think it's URL. href, I think, takes an extra argument. Yeah, there we go. And so this goes like a clickable hyperlink. You click that and then you get taken to Google. So there's a bunch of miscellaneous sort of tricks you can use. So renew command will help you sort of define your own command. That's very useful if you find yourself using this like particular long syntax and long sequence of commands a lot. particularly useful in maths mode. So like, let's say you're having a lot of derivatives. You can do something like dx dy, and then say this is equivalent to frac dx dy. And then if you have an equation, you can do just dx dy. Let's say whoops, what did I do wrong? I think it might be re command start. Or new command. One of those. I don't usually use this. All right, there we go. Yeah, I think it's new command if you want to make an entirely new command, and renew command if the command exists, but you want to change what it means. Sometimes you need to use renew command to like change a bunch of settings about the document, like the default font. So we've already talked about comments. New page is very useful, as well as vspace and hfill for sort of layout things. Hfill is good for like if you want a bunch of text and then one piece of text like all the way to the right of the page. Fbox is used to put some content inside like a frame. But Fbox and mini pages are really quite advanced stuff, but it's useful to mention them. So we also have lists. So we already talked before about enumerate. So you can have enumerate like this. Question, let's say step 1. This is step 2. And you can also have nested ones of these. So you can have another enumerate inside here. And then it will automatically like change the numbering. So it's like A and then I, and so on. You can use itemize with the Z to have a list with just bullet points. Yeah, and again, it will sort of change the like extra levels. Styling text. So we already looked at like text BF and text IT. That will make things italic, so and bold. So you can have like text BF here. There are some different fonts. So sans serif is the one that you can see all through these presentations. I quite like sans serif for like modern looking stuff. Roman is like the traditional sort of mathsy font. And then there's typewriter, which is the monospace one. And you can change the font temporarily using these commands. Or you can change the font for the whole document. Like let's say that, all right, I want this document to look super modern. Then you use renew command. Family default, I think it actually is. And then SF default. That's a mistake in the slides. There should be family default there. There we go. So now everything is in this sort of sans serif font, which is good for like, I like to use this for my CV, for example, because I think sans serif is in some cases easier to read. We'll get rid of that. You can also change the font size. So for example, maybe I want this step to be really important. So I can say this should be huge. So huge, this is step 2. And then we put these curly braces to say we want only that bit to be huge. Right, there we go. And we can sort of combine that, so we can make it bold as well. So let's say that this is really important. This is step 2. And then we can also make things smaller. So we can say this step 2 part 1, that's not very important. So we'll make it tiny. There we go. And we can use text superscript and text subscript to have like superscript and subscript without having to deal with like maths mode stuff. A little bit of extra stuff on styling text. You can add extra fonts. So if you like Times New Roman, but you don't want to use Microsoft Word, you can use, so you use the font encoding package that lets you load up extra fonts. And you can use this package, sticks to, it looks very much like Times New Roman, but you can use it in LaTeX. I think there's like slight differences. It also lets you use maths and the sort of Times New Roman format. So sometimes you might see like a document, like a paper or something, which has all these maths equations in it that look like they're done in Times New Roman. It's probably using a package like this. And you can also use, I don't know how to pronounce that actually, ZTech or ZLaTeX, to use true type fonts. So if you really want Comic Sans in your maths assignments, you really want to use, well, I don't think math assignments have style marks, but if you use Comic Sans, they'll probably come up with a way to have them. You want to lose those style marks, you can use Comic Sans for your math assignment. So there's another way you can have color. So you can use X color. You don't have to, if you're doing diagrams, you can have the color of the diagrams just fine. But if you want to have it for text, you use X color. So let's say I want, this one is important, so I also want it to be red. There we go. And you can also set the page color. So you can do your whole assignment in dark theme. So page color, black, and then we set the text color to be white. All right, there we go. We've moved into the future. So that's it for everything that I plan to cover. Are there any other questions or anything else that you'd like me to go through, or any of the extra material that anyone would particularly like to see? All right, thanks for coming. Well, we've still got a few minutes left. So as part of, maybe we'll go through, so as part of the workshop, I also put together some like templates for if you're doing like an assignment or a CV or something in LaTeX. So maybe we'll just spend some time going through those and what's in those. So this is like, this is like the starter document that I use for everything generally. So it contains the 4 packages that I think are sort of essential. It sets the paper size to A4, and then you can sort of add whatever you want inside the document. Nothing really to comment on here. I also have an assignment template. I believe most courses that want you to do an assignment in LaTeX provide you with a template anyway, but I figured I'd do my own. So this contains most of the commands that I think would be useful for an assignment. So it shows you how to do questions and then parts of questions and then a little bit of referencing. And it also includes the geometry package to set the margins to be a little bit smaller. And, you know, has all the stuff in there for titling your assignment. And then the famous LaTeX CD. So this is like a little template that you could use to do your CV in LaTeX. This is a sort of controversial thing. Some people recommend not doing your CV in LaTeX. I'd say talk to the university careers people about it, probably. Don't take any career advice from me. But I quite like to do this. The reason why people suggest you don't is because some companies, they have like an automatic CV reader that doesn't play well with CVs written in LaTeX and likes them to be done in Word or something. So it can be a little bit risky, but I mean, yeah, look at this. It looks really nice, right? So you've got, there's a few tricks here. So there's hfill here, let's say, for example, that sort of puts the date off to one side. That's very good for dealing with things that like happen over a time frame. It uses, I've sort of customized the way that the headers appear just to avoid dealing with sections. Sometimes they introduce a bit too much space and means you can't put as many things as you want on the CV. One thing that you can do is you can change the fonts up a little bit. So SC shape, this is for small caps. And then that makes it look like this. I've actually done this for the title as well. Yeah. Oh, I miss McDonald's Kingsford now. I haven't been to uni in ages. Yeah, I mean, feel free to use this if you want to do your CV in LaTeX. I've had some people ask me about that, like, how do I do my CV in LaTeX? This is quite similar to what I use for my CV. And maybe just a little bit, since there's a little bit of time, we can look at the source code for the slides for the talk. So it takes a while to compile all the slides. Oh, what's that? Oh, there's some files missing. All right, the live stream is finished on Facebook. So, all right, that's it, everyone. Thanks for coming. If there's any other questions, put them in chat now. I will make all the material available on the MathSoc website, and I'll put a link in the event description and stuff. And the recording will be made available later.
Yeah, just to jump in. So obviously I finished the live stream, but I can switch hosting privileges over to someone. If you guys just want to chill, ask questions, consolidate some of the information you went over, that sort of stuff.
Yeah, I guess that's fine. So, Rui, did you want to take care of the hosting, or Gerald?
I'll just make Rui. Cool, have fun. You guys can leave whenever you want.
Yeah, all the slides were done in LaTeX as well. I do basically everything in LaTeX these days, especially because I use Linux and I can't actually use Word, and sometimes I use LibreOffice, but most of the time I just use LaTeX.